afternoon. My name is Quoc. I'm come from Vietnam National University. Today I would like to present my study with title Capacitive Sensor based on the PCB technology for applicable inside fluid flow detections. So this is my content, the introductions and the designs and fabrication of fluid capacitive sensor, and then measurement, setup measurement, result and discussion, and finally the conclusions. So one question, why applicable detections is very important in many courses? Because an applicable occurs in blocked vessel, a body catalyst pattern to that. So people today try to develop so many kinds of sensor. You can see on the picture here that this is the uncharged unit sensor hold the pipe of block, and each time the air bubble occurs inside the sensor will give alarm. And there are so many applications of type sensor: infusions, dialysis, loss correction, and component separation instrument, and so on. So you can see here, this is a air bubble detector. This is a hemodialysis machine, and when the air bubble occurs, the sensor will give alarm. And then we have the conversions in ultrasonic sensors in the next picture. And this is a parameter. The charge channel is around 2.5, and the minimum volume of the sensor can be detected, that's 10 microliters. So for my study, we suggest for new type sensors. This is capacitive sensors, and you know there are so many advantages of capacitive sensors: easy to design, fabricate, low cost for commercial product, and long lifetime. And this is my sensor structure suggest. You can see on the picture with the PCB here, and we have two channels for reference channel and sensing channel, and we make the capacitive sensor here and here. And the next picture shows the three electrodes hold the vertical pipe. And we design the structure like in this finger. The three electrodes hold the pipe, and we have the simple equivalence C1, C2, and C3. And this is a structure with diameter. This is pipe is put inside, and we have the PCB. The thickness of PCB is around 1.4 millimeter, and the diameter is around 1.6 millimeter, and we have also the width of the electrodes is 1.4. And to understand this how the structure works, we use the commercial console software to simulate. So this is the structure. We use three electrodes here and hold the pipe, and we have the mesh model, and then we have the electrical field profile here, and we put the many size of air bubble inside the sensors, and we have the simulation results. The 6 air bubble, this is a relationship between volume air bubble and the capacitance change. So the sensitivity of this structure is up to 3 femtofarad per microliter. And so we go into fabricate. You can see on this picture, this is a restructure of 2 capacitive sensors. This is the copper and wire here, and here. And we have the reference channel, we have the sensing channel, and we make the system here. So in order to make the signal, so we use the charge amplifiers, and we supply the signal of sine wave, sine waves of 100 kilohertz. And as you know, so many because many noise here and here, so we cover this schematic circuits by the aluminum box. And this is the block schematic circuit. And the output voltage after go out the charge amplifier, then go to the looking amplifier, and we have the data acquisitions and data acquisition, and go to PC for data processing. And this is a measurement setup. We have the sensor here, we have the charge amplifier here, and we have the function generator and the NE data acquisitions and look-in amplifier, and then computer. So in order to generate the size of absorber, we use the special cylinder here and the Pham. This is to control the minimum the field of distance. So we have the oil pushed here, and we have the air pushed here. So we make the size of absorber. And after that, we do the measurement. This is the result. This is the output signal of absorber. You can see on this picture. This is the start point of when absorber start to Bluetooth sensor, and this is the point the absorber in the middle at the middle of sensor, and this is the point the absorber go outside. And we also have 4 absorber give the output signal here. This is smallest absorber, and this is biggest absorber. We investigate some size of absorber. This is the output signal of 6 absorber with different size, and we have the different so the different velocity, speed, and from that we have the finger. This is the relation between volume and the output voltage. Is linear. So we have made some calculation, and then the volume of absorber change, and we have the data, the changing of capacitance, and the measurement sensitive is up to 24 millivolt per microliter. So we compare both result of measurement result and simulation results. It's made together like on the finger. So this is my conclusion. We have in design and investigate of low cost and high accurate the capacitive sensors by on the print circuit board, and it's able to detect an absorber inside of fluidic channels, and also the volume and the speed of absorber can be recognized from the amplitude and width of the output signals. So the sensitivity and resolution of sensors is estimated to be 24 millivolt per microliter and 1.3 millimeters microliter. So we hope that in the future work we can reduce the size to microfluidic system, and we make some medical applications. Thank you for the stand.